Welcome, everyone, to the Information's TITV. My name is Akash Pasricha. It is Tuesday, January 6th. Today on the show, we are unpacking CES. We will break down the big announcements from Nvidia. We've got Kindred Ventures coming on the show, and our AI and robotics reporter is going to help us understand Nvidia's new self-driving car model. We'll then turn to some exclusive reporting, the information published this morning. AI evaluation startup LM Arena has raised $150 million at a $1.7 billion valuation. We will get more details on that. Next up, we'll turn to a story from our Amazon reporter about AWS's AI ambitions and how its homegrown models stack up against its competitors. And we will wrap with the closest look that we have taken yet into the different pockets of the energy and industrials sector that are changing their strategy to adjust to the AI boom. It's going to be a fun show, and so let's get right on into things. At CES yesterday, it was all eyes on Nvidia as Jensen Huang took the stage for his keynote. Two of his big announcements from the event were Nvidia's model for self-driving cars and more details about Rubin, the company's next big AI chip it is working on. The chip is supposed to be cheaper to use compared to previous models, and in some cases, companies should have to use less of them. I want to bring on Steve Jang, founder and managing partner at Kindred Ventures, to help us break it all down. Steve, welcome back to the show. It's great to have you here.
Thanks for having me. It's good to see you.
So you are on the ground at CES. Were you at the keynote yesterday?
Yeah, CES every year is a great moment for all of our hardware companies and compute companies to come together. So CES itself has a new life because of AI, which is great to see.
Nice. Well, I want to talk to you about the keynote. So look, the two big announcements coming out of Jensen Huang's speech yesterday were the self-driving car model. And I know you're close to that space, and so maybe we'll get there in a second. But I want to start with the new generation of chips that they gave us more details on, the Rubin family. What stood out to you about Jensen's speech about the chips? I kind of thought that we knew a lot of the stuff yesterday, didn't we?
Yes and no. I think everyone knew that the Vera Rubin super chip and the Rubin GPU were coming, but I think some of the details weren't widely understood yet. I think there was a couple concerns coming in. One was, is this going to be a drop-in chip to replace the B200s and GB200s? And it looks like it's not, right? So what you saw yesterday was a Vera Rubin super chip, a CPU and two GPUs. And then in a node, and then Rubin GPUs. So these are sold and delivered as nodes and racks. You can't just take a single GPU and replace your existing chips. So as in the data center, you actually have to change how your rack system works. So the rack is a system in this new Rubin series. So what you get though is 10x inference efficiency. You get 3 to 4x training efficiency, but it's going to require some work on the clouds and neoclouds parts. So it's a pay to play, right? They have to compete with paying up for a new series while they're still figuring out how to get delivered and monetize on the Blackwells. And so this is a continuation of the battle royale that the hyperscalers, the neoclouds, the inference engines, the frontier labs are playing right now. They have alliances, pre-commitments, bookings, and they're still figuring out how to utilize the last series of chips. So I think 2026, one of our predictions for 2026 is that this battle royale is going to be even more intense than last year. Many more bookings, many more alliances that you'll see. And they're going to have to fight for customers and still monetize and utilize all those B200s sitting in data centers and still getting shipped to them.
Right.
So the net though is that it's great for inference engines. It's great for frontier labs. It's great for neo labs. It's going to be expensive for neoclouds and hyperscalers, but long term they're going to be able to have the very best chips compared to anywhere else around the world.
Well, let me ask you this idea that you have to sort of replace the entire rack and it's not a drop-in chip.
Yeah.
Does that come across to you as a strategic move from Nvidia in a way to sort of ensure that customers are buying more of the whole system from them? Or is this an innovation, in the sense that you couldn't actually get the benefits that it wants you to get without buying all the other stuff around the chip?
My understanding, and we've just had a sort of day to look at this, but my understanding is that it's not a business decision; it's a technical systems decision. That this is how the Vera Rubin nodes and racks will work. I don't know if you saw the picture of it. It's a golden monolith,
Yeah.
beautiful. My comment at the time was, "Hey, looks impressive. Also looks very expensive." I mean,
Yeah.
that's why they colored it in gold, right? And so I think this is a system as a rack solution, and I don't know that it's a pricing or a business decision so much as it is. This is the new rack system and node system that they want to push out there, and that's a technical requirement. And so, well, we'll find out more in the coming days. But I think this is really interesting because it's a replacement cycle. It's like the same way that consumers replace their iPhone for the next iPhone.
Right.
Um, their old iPhone, their current iPhone still works, but they want the next one. And I think basically the entire industry, the compute industry, is essentially on the
This
iPhone
replace
replacement cycle.
the Nvidia replacement cycle.
Yeah, you don't need it yet, but you'll need it soon, and so you should get it now and book it now. Otherwise, you might be waiting in line and then a slip on your competitive race with others. So I
I
think,
will I will say it's funny to me. Was I was watching the live stream, and I was on YouTube, and wherever I was watching it, the comments underneath, the top comments were, this is the consumer electronics show. This is like, one of the least consumer things. And look, I know you say all of AI rests on the chips, right? And at
yeah.
the end of the day, it all comes back to it. But some people were saying, gosh, it's getting more and more technical, and in terms of what's being announced at these events.
I mean, CS has always been a mix of some consumer devices and a lot of infrastructure. The server companies, the chip companies, the component companies have always been out here. This is sort of it's always been sort of the trading, order filling convention from a
Right.
long time ago. But it's 1,000x now because if you think about all the keynotes, like very few of them are actually touching the consumer, right? You saw the AMD keynote, you'll see a Siemens keynote, you'll see so many keynotes from companies that are 2, 3 steps away from the consumer, but it's super important, right? This whole Vera Rubin series that they announced, it's built for a future around consumer agents and enterprise agents. That's why they built this. The prediction is that over the next year or two, inference workloads will exceed training workloads, which will be the first time that's ever happened. And so this is made for agentic workloads. The number of requests that you're making on an inference level requires a tokens per second per watt calculation we just haven't seen in the industry. So as companies like Perplexity and Claude Code, you see what they're doing with their harness on top of their Opus models, Codex, things like that. These agent platforms are going to use up so much inference that you need a different chipset and a different system. And so
Let me ask you about
that,
consumer workloads. Was definitely a focus yesterday, but a lot of it too was physical AI, right? I
mm,
mean, manufacturing, robotics, and we had a good story about that yesterday too. How Nvidia is really gunning for this category of customers now with its Omniverse suite. What do you make of the focus on physical AI? Because it wasn't just Nvidia yesterday. I think other chip companies as well announced more products targeted towards these sort of industrial
yeah.
applications. Why is this such a big focus now? Is this where they have to look for growth?
No, I don't think the narrative is that they have to look for growth, and so they're sort of forcing this theme. I think that this is a theme that's been brewing. I mean, if you think about what a chip maker, and Intel used to do this a long time ago, but what NVIDIA is doing is sort of setting the mandate for the conversation and providing the tools for that conversation and that building to happen in a sector. So essentially, it's sort of like king making, right? We often talk about
They're setting the tone.
Yeah, do venture funds king make companies? Well, I'll tell you, Nvidia is king making sectors, right? And so, what you're seeing is that they did this with LLMs, right? They focused in on LLMs, and had great things to say about not only OpenAI but also XAI and Elon Musk's ability to stand up a data center very quickly with, lo and behold, their chips inside, and then they king made on the robotic sector, right? And you saw that with Groot and everything that they were doing there. And now, when they say physical AI, it includes robotics concepts. It also includes VLAs, right, and VLMs. And so they're not. These are derivative technologies that are improving over time in the industry. If you went to any of the ML conferences over the last year, like ICML, ICLR, NeurIPS, you saw that physical AI was a huge theme. And so world models, everything from world models to robotics models to autonomy is part of physical AI.
It's very much the narrative that people want to attach themselves to right now.
Yeah, and if you saw what they announced yesterday, they have open data sets. They have open source models, right? They showed that demo video, and we know this well because one of our companies, one of our portfolio companies, Neuro, is an Nvidia partner, is invested in by Nvidia and Uber, and they launched their Neuro car with Lucid and Uber, and it's AGX Thor inside, Nvidia chips. Right, and what Nvidia basically shipped yesterday, very interesting, is that other auto OEMs and other technology companies can use these models and their chips, right? Their chips are always inside.
Right.
And this accelerates the ecosystem so that using open source, which I think there's been an argument that what is this purpose of open source from a monetization perspective? Well, in this case, it sells chips. And then the second part of that, of what I thought was super interesting, is that they basically offered a hardware, model, and software kit to create your own Tesla FSD or your own Waymo. So when they're
Anyone can, it's very much democratizing who can develop on this technology. I think that's a good point. Actually, I hadn't thought about that. Very quickly, after all these announcements yesterday, the stock didn't really move. And look, Nvidia stock is kind of, a tough thing to predict. But what did you make of that part of this?
Yeah, from a public stock perspective, I think a lot of the Rubin stuff, announcements, and even the physical AI, there's been data out there, right? Neuro's been using Thor, and with Uber. Uber was announced as a Nvidia partner as well. So a lot of this stuff is already probably factored in to a Wall Street's pricing. But the other thing that's interesting here is that if you look at Nvidia today, they are pushing forward an agenda against the narrative that is there a bubble? And there's another counter narrative, which is Nvidia's throne at risk because of TPUs from Google, or is it at risk because of inference chips? And what I'll tell you is the Vera Rubin family, that series of chips, it's 10x improvement in inference. So it kind of calls into question what was the narrative that was floating around the Grok acquisition. And I still think that we have some
Does it
breakfast.
make you does it make you question the Grok acquisition a little bit then?
No, it doesn't actually, because I think the Grok acquisition, we'll see if they actually use the Grok chip license in their product suite. I think if they do, it's heavily modified to fit into NVIDIA's suite. But what I think it was getting one of the world's best teams in inference. We when we looked at that, it was like the SRAM innovation that Jonathan and team had achieved. There's very few people on the planet that know how to do that, and I don't think that's not in the wheelhouse of NVIDIA. So I think that was essentially a $20 billion talent acquisition, right?
Right.
All Meta.
Which is very much what they kind of call it by doing everything but the acquisition. I mean, they didn't call it an acqui-hire, but
I mean,
I
regulatory,
yeah,
FTC
yeah,
issues aside, it's a great talent acquisition, and 20 billion is a lot for any company other than Nvidia, right? And
right.
so, when I look back at the Grok acquisition, they didn't take Grok Cloud, right? They have DGX Cloud, so they don't need that. And I think that they're going to build a new inference chip that's focused on tokens per second, and it's not focused on training, obviously. And And if you look at what they're offering here, it's saying you can pay to play here, and you can get a much more performant inference and training chip in Rubin. And we're probably going to offer you at around the same time, maybe a little bit after,
Right.
an inference accelerator that is single focused on that outcome and that use case. And so, I think as this unfolds, I think there may be a little bit more upward pressure on that price, but I think people are still grappling with a couple of these narratives. And so we'll see how that plays out in the future. But, the Rubin chips aren't coming out for a while either. So
Well,
I
and I think we were all excited to get more details on it yesterday, and we didn't have time to get to the self-driving car stuff, but we're going to talk about that in our next segment with our AI and robotics reporter, Steve. I want to thank you for joining us. Have fun at the rest of CES and enjoy the rest of the week. That is Steve Jang, founder and managing partner at Kindred Ventures, here on TITV. Okay. Sticking with our CES coverage, I want to bring on our AI and robotics reporter, Rocket Drew, to help us dig a bit deeper into Alpameo, the self-driving car model that Nvidia unveiled yesterday. He wrote about that in our AI Agenda newsletter out today. Rocket, welcome back to the show. It's great to have you here.
Hey, Akash. It's great to be back.
So we just talked about the chips that Nvidia unveiled or gave us more details on. I want you to explain to us what exactly Alpameo 1 is, because it's Alpameo 1.
That's right. There's
And
more to
what
come.
is this model supposed to do?
Yeah, it's a model for self-driving cars. So it's trained on a bunch of data that people have collected by driving their cars in the real world. And then a lot of data besides that, that's sort of generated in computer simulations using NVIDIA's own computer simulation technology, in particular using Cosmos, which is their sort of mainline AI world model. And the model is intended to drive cars. It can predict what action a car should take based on a state of the road, based on an input image. The model itself is it's pretty big. So if anyone was going to use it in practice, you'd typically customize it a bit on your own data. Maybe you distill it into a model that's smaller and faster so it can run in the car itself. But it's intended to accelerate the development of self-driving technology in a number of ways.
And so how does this model compare against other self-driving car models? I mean, we know that Tesla is working on their own robotaxi suite of cars, I guess. I mean, presumably they have their own model. I don't even know. Is this a very competitive landscape?
I think a lot of it's locked down and very proprietary, so it's difficult to say what Tesla is doing. I mean, Tesla has made a pretty firm position that they're interested in using camera inputs only. So they want their car to be able to maneuver the world solely based on vision rather than using additional sensors like LiDAR to estimate how far away different objects are. And then the biggest difference, I think, is that this model is it's open source, so anyone can download it, anyone can tinker with it and experiment and customize it, and that makes a big difference for the model. It's also not intended to provide, so-called level 4 autonomy right out of the box. The intention isn't that you can put this in your car tomorrow and you can stay home while your car drives around for you. At best, as they're starting to roll this out, working with Mercedes-Benz, it's going to hit the road at level 2 autonomy, which means
And the difference, right? The difference between 2 and 4 is
it can tweak your steering and your acceleration, speeding up and slowing down, but you've got to be vigilant the whole time. You've got to be ready to take over and take the wheel if anything goes wrong.
got it. So you wrote about this being an end-to-end model. What does that mean?
That's right. So the traditional approach in a lot of robotics, including for self-driving cars, is you have specialized pieces of software that are governing everything the robot, or in this case, the self-driving car, needs to do, from perceiving the world and making sense of it, to planning what actions to take, to controlling the robot or the car in taking those actions. And you'd have a separate layer of software that handles each of those. That has some really nice properties. Like, you can tell when something's going wrong. I know it's going wrong with the perception part of this process. And you can see the flow of information from one to the other. But with the rise of AI, it's very in vogue these days to just have a single unitary AI model that from pixels coming in to actions coming out controls everything that the robot or the car does. And that has some real advantages because, AI models are so expressive and powerful. They can capture all of these difficult to define rules and they can learn from data in subtle ways. On the other hand, now you're letting some black box that you can't really monitor, that isn't very transparent, control your car, and that's a very high stakes kind of robotics, right? That's a very serious deployment. So
And
it also
you don't
brings
actually, if something goes wrong, you don't know what part of it actually went wrong because it's not as segmented.
exactly, and something, it's always going to encounter some scenario it's never seen before. You're always going to come across something on the road that your model didn't see during training, and you want to make sure that it's going to be able to
Yeah.
handle it properly.
Do you want to share the example that you gave in your newsletter?
I had SantaCon on the mind. I'm thinking, if one of these
A
self-driving cars.
parade of drunken Santas is the obstacle that Rocket decided
That's right.
he was
You
gonna
know
put
that's
in
not
front
in
of.
the training data, you know? You know
Yeah,
that, Nvidia isn't simulating those drunken Santas during training.
right. So, I mean, I do want to ask you though. I mean, so there are pros and cons. Why do you think Nvidia went with that end-to-end approach? Then was it really just a way to differentiate itself? Is it a way? Is it a business decision? I
Yeah,
mean, you're saying it's open source, so I mean, presumably there's a lot more there that people can tinker with. I mean,
I think
walk me
it
through.
Yeah, I think it really showcases their simulation software. I think that's really how you get a lot of juice out of this Cosmos model that they've put out, and they're trying to drive adoption of it. And then I think they want people to spend compute. To Steve's point earlier, NVIDIA wants people to spend compute on actually running this model, and I think that makes most sense in this kind of end-to-end paradigm as well. But NVIDIA does something clever, right? They don't just rely when they're actually putting this model out into the world, when they're working with Mercedes, they're not relying just on the end-to-end model. In parallel, they're running the more traditional stack of perception and planning and action. And they're both systems at the same time are deciding what action should we take. And they have sort of what do they call it? Like a safety policy evaluator on top. It is a fancy way to say they have another system that's deciding at any given moment which one should we listen to. Do we
Hmm.
trust what the black box
So,
model is
so
going
it
to say?
decides. You
It
either go with
decides.
the new model or the older
Right,
technology.
right. Based on how confident the models are, based on are we in a novel scenario that the model hasn't anticipated, and that adds a level of safety to it because you can guarantee that we'll fall back on the safer model in the event that we run into some exceptional circumstance.
Right. I want to shift to talking about another scoop that you published today. You and Katie Roof, our deputy bureau chief of venture capital, had a story about LM Arena, and I gave it away here in the heading, but the reporting showed that it's valued at $1.7 billion in a new funding round. Tell us a little bit more about why the LM Arena was able to raise all this money.
Yeah, absolutely. I mean, Elm Arena has become a go-to place to compare the capabilities and performance of models. I can tell you, I talk to people in AI all the time that look to Elm Arena for a sense of how different models are performing to gauge the quality of new releases. It's really become a source of common knowledge for how different models perform at different tasks, from answering questions to generating images to generating videos from images, like you name it. Marina is creating a category to compare models.
How does it make money?
So it has a small army of people who, for free, are comparing models around the world and telling you, you know, ChatGPT is doing this and Claude is doing that. That data that El Marina collects is really valuable. I mean, that's a super valuable signal for AI companies to use to improve their models. So El Marina works with AI companies, both the model developers and bigger businesses that are working on deploying these AI systems, and it gives them custom evaluations. Like a company comes to them and says, we want to know how well it's doing at a certain category. And thanks to El Marina's the data that they've collected, and thanks to the sort of free workforce that they have, they're able to provide really, sort of useful evaluation metrics and compare. They can tell you ahead of time, this is how your model is going to stack up.
So it's basically I mean, it has this public benchmarking system for the public to see, but then privately, it can get paid by these labs to basically give feedback on
Exactly.
how good their models are.
Exactly.
And you know, I imagine there's like a wall between the two and saying, "Hey, the feedback that we give, like they'd have to really say we're not picking favorites, right? And we're closer to this lab and this lab. We have more business from this lab, and there would really have to be a wall in
Yeah.
saying we don't mix the two."
Yeah, and they've come under some criticism for the practices related to this in the past. There was a paper that was published a while ago that was headed up by Cohere, and Cohere was criticizing that it seemed like Meta, in advance of releasing one of its Llama models, was able to sort of pay to play. And I think the way you're pointing to, they could submit a number of checkpoints for the model that were customized in different ways. They could see which one performed the best, and then they could go with that one. So on the day the model comes out, it seems like it's performing very well against the others. Now, El Marina has responded to this extensively and has explained their practices and how they go about it. But you also might say, what's the harm? You could say, well, sure, Meta is willing to pay more than other customers, but the feedback they're getting, if it's high quality, is leading to the best version of Llama that they could possibly release. So that's a position you could have on it as well.
Right. Well, Rocket, I want to thank you for coming on. That is Rocket Drew, our AI and robotics reporter here at The Information. Okay. Amazon's AI team has been in a stressful spot lately, trying to make sure that its own models are up to par with the many outside models that the company has on its platform. That is the subject of an in-depth story out today from Catherine Perloff, our Amazon reporter, and I want to bring her on to tell us more about what she learned. Catherine, welcome back to the show. It's great to have you here.
Hi, Akash.
So, we've talked a little bit about Amazon's Nova models on this show. It's not the model that we really think about first when we think about, the leading companies, and yet this is AWS. So, how good is the Nova model family? And it's a loaded question, but let me know what you found.
Yeah, I think that Nova, they just released the second generation of models at the end of last month, and Nova has been improving on a lot of metrics, and in some metrics it's even better than Anthropic or OpenAI, but on a lot of metrics it still ranks behind those big companies. And um people, external customers I talk to, find that it's kind of reliable, it does the job, it's cheap, but it's not state of the art, which is why some employees who work at Amazon have actually taken to calling Nova Amazon Basics, which is a little bit, cheeky because
Kind of a
that's sort of
dig. Kind of
yeah,
a
yeah, because that's the private label line of the e-commerce site. So, they're getting better, but they're still not quite top of the line, I guess, is kind of where we're at.
And just explain it to us. I mean, so AWS is obviously the cloud business, and so on that platform, customers have the choice of using either the Nova models or Anthropic or any other number of models, basically, for their purposes, and they're able to do the comparisons on their own, saying, this one works better or worse.
Right, exactly. So, yeah, AWS, offers a variety of models. They have this Bedrock service that is where their customers can, build products on these models. I think that Amazon would say publicly, and I think there is definitely truth to it, that Nova is just about them offering more choice, especially to their AWS customers. What there should be more models for their business customers to not have to be locked into a couple big players. But obviously they're also trying to invest in building their own models for their you know for their own business reasons. And that's something we kind of get into in the story is if Nova is not sort of good enough on its own, especially to underpin Amazon's own products, is that going to be a problem for Amazon?
So, what is it doing to improve its Nova models then?
Yeah, I mean, I think that, they did improve in the past year. They announced the first generation last December at the AWS conference, and now they've announced a new generation. They've gotten, better on a lot of different metrics, like, some including like rule following, and other benchmarks. I know Rocket was just talking about LM Arena,
Right.
those kinds of evaluations. But Internally, there is concern that it doesn't always do the job just as well as or as good as Anthropic, especially when folks are making products. So a lot of like flagship Amazon AI products like Rufus, like QuickSuite, which is an AWS enterprise search product, Curo, which is a coding assistant, you know, use Anthropic and Nova, and actually Curo relies exclusively on Nova. And sorry, the endings are confusing. And I talked to some of the folks, who had worked on those, and they said that AWS leaders want them to build more on Nova because they're worried if too many Amazon products are built on Anthropic, those products won't stand out on the market when any company can build products on Anthropic. And Nova is sort of Amazon's special sauce. So they are also making it available to other customers. And they've been instructing their employees outside the AI lab to work on kind of fine tuning, post training the Nova models to improve them. And make them kind of up to speed. And some of the people I was talking to weren't working with the newest generation of Nova models. Some of them were working with models that were kind of coming out this year, but maybe not quite the ones that were announced at reInvent in December. But nonetheless, they had found that, they were post-training these models, but they're not always doing quite as good a job as they want them to. For some things, they're okay or even, better, but for not everything. And that's why there's had to be some reliance on Anthropic.
So let me ask you this: you've just started covering Amazon in the past couple months, and this was one of your first of many, I'm sure, deep dives into the AI business. And I've always really tried to understand, what happened that sort of had AWS, in some cases, fall behind, I guess, in the AI conversation, in a way that the other cloud providers didn't. And I wonder, as you sort of coming into this beat fresh and looking at this, what is your sense for what happened at AWS, and why they haven't been at the top, the way that GCP or Azure have been in the AI conversation?
Yeah, I mean, well, Google has the advantage of being one of the inventors of, this
Yeah,
technology.
yeah.
Um, Microsoft has really thrown its weight behind OpenAI, and their relationship with OpenAI is more in depth than Amazon's relationship with Anthropic. I mean, Microsoft has also tried to develop its own AI models, but it's had this sort of very deep partnership with OpenAI and certain exclusivities to that partnership, which Amazon and Anthropic, you know, um, I guess,
It's a newer partnership,
yeah,
really.
and Amazon and Anthropic has also been cozying up to Microsoft and to Google. And then, and the last kind of player we can think about is Meta, which has just been throwing a ton of money at this problem. They don't have a cloud business, and I guess maybe that's part of the reason they've done this is Amazon kind of has this cloud business where AI startups, will use it to sort of insulate them from some of the market pressure. But Amazon's culture is not to spend so much money. That's never been their culture. They've always been a bit thriftier. That's something else we talk about in the story is, they weren't paying like exorbitant salaries like Meta was, and they had a bit of a more careful approach to retention. And so I think that it's sort of like kind of, I guess, like a double-edged sword where like they weren't so advanced in AI like Google, where they didn't have to, they had this head start that you could say Google didn't in some ways. I mean, they just had Alexa, which wasn't seen as advanced AI, but they
And
weren't
and you
so
talked to the story about a lot of the talent from the Alexa team sort of migrating over to work on AI, right?
right. That's where they kind of drew the talent for this AI lab. And there's some kind of debates internally. Was this the right talent? Because the folks working on Alexa AI were not as well versed in sort of large language models versus kind of other older forms of AI like natural language processing
Right.
and machine learning.
Which
So
is actually kind of, if I think about this, we've written about Apple's struggles to get Siri to scale the way that would have hoped with new AI features. I mean, it's sort of the same. Alexa and Siri, the same group of talent, I guess. You could make the argument that maybe relying on that type of talent to scale your AI strategy maybe hasn't boded well for both of these companies in some in
Right.
that
Yeah.
case.
I mean, to be fair, Amazon has done some of those sort of hiring licensing deals. They did one with this agent specialist startup Adapt last or 2024. We're in 2026.
Yeah.
Um, and they also work with a robotics AI company, or they did the same with a robotics AI company, Covariant. Um, but yeah, I think people have made the Apple comparison. And I mean, just to kind of show how this strategy is in flux, last month they announced new leadership for this AI organization. The person who had been leading it is leaving. They're getting in an AWS exec, and they're making this kind of division, which had just been focused on making foundation models, also focus, also have chips and quantum computing in its purview. So I think they're trying to sort of address the problem. But yeah, Apple is sort of a fair comparison to sort of uh, how they compare within the big tech companies in
Right.
the AI race. Yeah.
Well, it was a great story, Catherine. I want to thank you for coming on and sharing your reporting with us. That is Catherine Perloff, our Amazon reporter here at The Information. Okay. The AI boom relies heavily on the energy sector. And in our newest edition of our AI infrastructure newsletter, we look at all the different corners of that industry that are changing their strategies as more data centers pop up. Joining me now is Ann Davis Vaughn, our columnist and the author behind that newsletter. Ann, welcome back to the show. It's great to have you here.
Hi, Akash. Great to be here.
So, we've talked on the show about the extent to which the AI boom has been a big boon for the energy sector. We haven't really gone as in detail as your column did today about what corners of the sector are actually benefiting and changing their strategy. You talked about utilities, you talked about equipment manufacturers. Lay out the list for us, rather, of who's benefiting, and then talk about what you're seeing from your reporting.
Yeah, absolutely. So I wanted in this column for our readers to understand all the different players that are getting something from this AI race. The incredible resource demand for energy, um, to launch AI is the catalyst, but this is a moment that many industries are trying to seize because it is we've got a extraordinary need, not just for energy, but for industrial resources, and a moment in time that companies see where some policies could change for them. So this boom is about thinking it, thinking about this boom, you want to think bigger than just what's happening in Silicon Valley. Um, what we talk about in the column are, among other things, what the natural gas industry is able to use this boom to do. And so I'll just give you an example. The natural gas industry is seeing the AI race as a generational opportunity to get some aspects of their agenda accomplished that they have not been able to get accomplished for a decade or two. And that includes building more permanent infrastructure for natural gas pipelines and natural gas plants, because they can argue that this AI race must be won by the United States and that they have a part to play.
And in some cases, you talked a little bit about how this investment, I mean, sometimes it doesn't really matter if it's the cleanest energy source, right? I mean, because there's such a shortage.
There's such a shortage. I would say, you'd be surprised at over time, best practices in the energy industry can help clean up. It's been a motivator for the natural gas industry to um, be a partner to some of these tech companies by saying, "Hey, we're going to clean up our, methane leaks from some of our operations." Or there are deals in the works right now to try first of a kind projects that would include carbon capture. So uh, that's one industry that is benefiting and seeing their moment. Clean energy companies are seeing their moment because we need so many different energy sources and different regions of the country will be able to use energy infrastructure in different ways. Batteries are absolutely booming, especially in Texas, as a backup and a pairing to solar. And entrepreneurs in those industries are seeing incredible investment, despite what you might hear about the Trump administration's policies not being as supportive. And they're not the only ones. The nuclear industry, including the whole nuclear supply chain, because we are reviving nuclear power plants, is revving up to help this incremental need for power. And that also extends into mining companies for domestic uranium. It extends into equipment companies that are building out what goes inside of the data center, electrical equipment providers. Um,
And what happens if the AI bubble bursts, as people fear it might? I mean, these data centers, there are multi-year commitments to build them, and I can't help but think of our colleague Steve Levine's reporting. We have an entire database dedicated on the information website to the gigafactories that popped up to make these, I think it was the batteries for the electric vehicles and the materials, stuff like that. And some of them are just, I mean, they're just shells now. I mean, they've been gutted, or in some cases they didn't even get going. What happens if this investment goes away?
Yeah, yeah. I mean, you're seeing some battery companies pivot into utility power. So there's a few interesting things about this, Akash, because the industries that I wrote about in my column think in terms of decades in terms of their projects, and they're trying to help an industry that is thinking in a 12 to 18 months time frame, and how quickly can they achieve what they're trying to achieve with their, getting some sort of product revenue with AI. But uh, these industries have, been through booms and busts before, and they're being really careful about who they engage in these big long-term contracts with. So it could ultimately give the very large tech giants an advantage over time because, if you're going to engage with the oil and gas or gas company, that can also do carbon capture or that can help you with the pipeline, they want to have a credit-worthy counterparty. Um, that's one way that the energy companies are protecting themselves. We also just explain the nature of the utility business in the column. Utilities have been granted a monopoly in territories, especially in states that have heavier regulation, and they go to state regulators and ask to do multi-decade, capital expenses. And once they get approval, they have a guaranteed rate of return that is built in that they can charge to their customers, including data centers. And those projects are then pretty durable because we're all paying for it. And the interesting thing is that we are so behind on power infrastructure, and we have so much more that needs to be invested in the industrial base, that this capacity that we're building is likely just the beginnings of what we need in this country. And it goes so slowly, some of it. That is a natural governor on the energy infrastructure bubble.
And the fact that we sort of have an excuse now to accelerate things is sort of more reason to say that maybe these projects, they won't actually be canceled in the long run. And I want to thank you for coming on. That is Ann Davis Vaughn, our AI infrastructure columnist here at The Information.
Thanks for
Okay. Well, that does it for today's show. A reminder, we are on this stream Monday through Friday at 10 a.m. Pacific, 1 p.m. Eastern. I want to thank you for tuning in. We really do appreciate your viewership. I am already excited for our next show tomorrow. Have a great rest of your Tuesday. Bye-bye for now.